Kia ora, Year 12. This video is going to go through a couple of merit questions from last year's integration paper. So I'm going to start with question 1C. So we have to find this integral here. And I guess as soon as we see a fraction inside an integral, we should be thinking about the pattern that we want to get, which is this, the derivative in the numerator and the function down the bottom. Now we don't have that here. So what we're going to do instead is look at, we've got x minus 3 here and we've got 5x. So we're going to divide this out as follows. So we've got 5x, what is it, 5x, take away 11 over x minus 3. And with a tiny bit of rearrangement, we can get the pattern that we want with the derivative in the numerator. So we've got x minus 3 here, so we can force in the 5 times x minus 3 here. And that gives me 5x minus 15 in the numerator. I don't want that, I want 5x minus 11. So I have to add in 4. So now what we've got is the integral from 8 to 4 of just 5 plus 4 over x minus 3 dx. And that's very straightforward to integrate. That gives me 5x plus 4 times the natural log of the absolute value of x minus 3. So just check that this has a derivative of 1, so we don't need to make any adjustments. And it's fine, right? So we just have our plus 4 sitting here, and that's all there is to it. And now we just have to evaluate those limits. So that gives us 40 plus 4 times the natural log of 5 minus 20 minus 4 times the natural log of 1, which is 0. So my exact answer is 20 plus 4 log 5, and my approximate answer works out to be, what, 26.4, I think I got 0.438, but I can't read my handwriting. I think that's right. Okay, so on to the second question, which is a bit more interesting. The graph shows us the curve this and the line of this. And we have to find the shaded area. So there's nothing too bad about this question. This is the kind of classic pattern where we've got a function here and we've got a function here, g of x. And if we want to find the integral, the area between those two curves, this is what we need to do. We have to do f of x minus g of x. Okay, so the first thing we have to do in this case is figure out what these x limits will be. So we need to equate the two functions. So that gives me x plus 3 over x is equal to 4, which is a quadratic. We get x squared plus 3, multiplying everything through by x, equals 4x. Happily, it's a really easy to factorize quadratic. So now we look at this, and we can see straight away that it's going to be x minus 1 times x minus 3. So those are the two values for the limits here. We've got 1 and 3. And the top function here is the line y equals 4, and the bottom curve is this one here. So we're good to start integrating now. So the area will equal the integral from 3 to 1 of 4 minus x minus 3x. I'll do that really slowly there. That's what we've got. Now, it probably is worth doing it that slowly in the exam because you really don't want to muck the negative and the positive signs up there. Okay, so now integrating this is straightforward. We get 4x minus x squared on 2 minus 3 times the natural log of x with the absolute values between 3 and 1. That gives us 12 minus 9 over 2 minus 3 log 3 minus 4 plus 1/2, and then this becomes 0 because the natural log of 1 is 0. So that gives me, and I know some of you are going to put it in your calculator like that, but don't, just clean it up first. So we get 8 minus 9/2 plus 1/2, so that's minus 8/2, so it's 8 minus 4 minus the natural log of 27. So now you can throw into your calculator, if you have to get an approximate value, 0.7042. Now, I sound like I'm joking about that, but actually, because we're doing level 3 and they haven't asked you for an exact value, I definitely would go through to this point here. And I've done that to 4dp. Okay, thanks for watching. I will keep on chugging with the rest of these over the next few days. So if you've got any questions or any exam questions that you want me to speed up and do quickly, just send me an email or leave a comment.